Fatima. Good morning, everyone. We will be starting, inshallah, in a minute. Thank you all for joining. Alongside myself is Miguel, and he is going to take the lead in this presentation. So without further ado, Miguel, please, you can start.
Thank you, Saif, and good morning, everyone. And yeah, welcome to this webinar in preparation for the hackathon that we're going to be running next week on Tuesday and Wednesday. As Saif mentioned, I'm Miguel Castro. I'm coming from the Planet team based here in Germany. And I will be basically with you during today's webinar and also next Tuesday and Wednesday together during this time. We're going to spend together to know more about how we can use Planet satellite data to address global challenges. So the idea for today is to give you an overview, first of all, of the event. So to review the agenda with you so we are all aware of what we're going to do and how we're going to spend our time together. And also, I will use the time we have today to introduce you to Planet. So we have that done in advance, so you're aware of well, the satellites we have available, our constellations, and the little details that are needed to work with our data, so that next week, once we are there all together, we can just start working more in detail with the data and for you to start to build your applications. So I'm gonna share my screen here. There we go. Okay, so as I was mentioning, we're going to be covering throughout this almost 2 hours that we have together, the basics of Planet, to have this understanding of how we work here at Planet, how we build our constellations, and which are the characteristics of those satellites, etc. So just to have this common understanding. And of course, if you have any questions, any doubt, both regarding the hackathon and what's expected, but also about Planet or anything that I'm going to introduce myself, feel free to basically ask any question. You can either post it, I believe, in the Q&A section here in Zoom or in the chat, or I think we are not that much of a large group, so you can also unmute yourself and interrupt me. That's totally fine. So let's get started. And the first item before going into the details of Planet and everything is to talk or go through the agenda we're going to be together the next week. So as you can see, we are expecting you on Tuesday 10th at the SRTIP location. And the first day we're gonna we will be starting at 10 a.m. in the morning UAE time. And we will spend just the first 20 minutes just getting to know each other. Although I think today is also a great chance to understand what you are doing. And if it's okay for everybody, also, I would like to do at the end of today's session, just a quick chat, a Q&A for just to talk to you and understand what's your profile, what's your background, and how you think you're gonna develop during this time. So we will have this 30 minutes introduction over there, and we will then just start straight ahead at 10:30. We will be covering the basics of the Planet APIs, which gives us access to the Planet data and really allows us to exploit everything that Planet is producing in a very operational way. So I think it's really important to have that understanding. And the first day is going to be for the rest of the time covering one of the most important APIs that we have at Planet, which is the data API, the one that really allows us to access the full archive of daily imagery that we collect at Planet globally, and that allows you basically to take that and create pipelines and applications on top of that. So the idea here for this day would be to enable you to access and discover the Planet archive, so you can find any product that it's suitable for your application, and you know, and you will be living this day knowing how to do that. As you can see, we are let's say we will be running the teaching part of the hackathon from 10 in the morning until more or less 3. Then there will be a dedicated time until 6 p.m. for you to work together. So the idea there is for you to make groups and just work on your ideas. So I will be around, obviously, during this time, just helping you shape those ideas in case there is any issues or any doubts about the tools, about the applications as well. I will be there guiding you the best I can. So be aware that there will be both a teaching time and then, let's say, a self-working time for you to put in place what you have learned that day, but also start working on your applications. On the next day, on Wednesday, we will follow a similar approach. In this case, we will start the day directly with the practice. So we will, in this case, jump into a second API that is fundamental with Planet, which is the Orders API. Very briefly, this one allows you to ask for, let's say, data in bulk. So it's really put in place to create those pipelines and ingest automatically a large number of Planet products. And as you can see, we will dedicate again also some time at the end to allow you to work together. You're going to have access during this hackathon to a planet scope of data. We're going to cover today this satellite and the characteristics of the data. So you're going to have access to that from the beginning of the hackathon until the end of November. So definitely this session next week is the starting point for you. It's where we want to make sure we enable you. We want to make sure you have the chance to ask any questions in person to Planet, to meet. And after that day, you will be set to develop at your pace any potential application that that you're interested in. I'm seeing, I think, some questions. No, okay. Yeah, okay. I thought there were some questions, but it's just people trying to enter. Okay, so this is the setting we will have. And as I was mentioning, during the working time, by the end of both days, we expect you to group together and well, just start to develop your ideas with the knowledge maybe you bring from your own background, but also, of course, with what you have just learned that day. So if there is no question about the organization, about the 2 days event that we're going to be there together next week, if that's all clear, I would say let's start with the presentation. I believe there are no questions. Okay, so let's get started. So let's do so by basically starting from the beginning. If we think of Planet and what's our mission here and what we are trying to achieve at Planet. So the mission basically has remained the same since Planet was founded in 2010, and that is to image the entire world every day and make that information visible, accessible, and actionable to anyone. The whole hackathon idea is around that mission to make that information accessible to you, so you see how it can be done with our tools and provide you with access to this data with this daily scan that we do globally, so you can create applications and monitor changes that are occurring worldwide. One of the main characteristics here at Planet is our approach to what we call agile aerospace. So basically, since the beginning of Planet, technology was the first, let's say, objective, short-term objective was to demonstrate that technological possibilities of launching satellites in a different way. So we are not here addressing satellites that are the size of several hundreds of kilograms or anything like that. We're putting the state-of-the-art, the best technology that is off the shelf available and making satellites with that. And this is allowing us to create these huge constellations that are able to scan the globe every single day. Of course, following that approach requires, and it is by design something mandatory, that we are agile in those processes. We need to stay on top of what's available in terms of technological characteristics and components to make sure that we are putting the best available in our satellites. And again, this comes back to this concept of agile aerospace. So since the beginning of Planet, we have been releasing new satellite designs on a regular basis. And for that, we use this specific concept, right? So rapid iterations and testings are key to this method of developing aerospace, or in this case, satellites. And definitely it's cost-effective to both manufacture and launch. What you see on the picture here is what we call the Dove satellites. And those are definitely designed and tested on ground, but definitely part of their life cycle is also to be tested in space, so that we can check which are the characteristics, the features that work, and then make modifications and come up with a stable version that we create in our labs, and then they're just sent back. So this approach of agile aerospace and introducing changes that are tested both in the lab but also in space has allowed Planet to create 17 different builds of the Dove satellite in just 10 years. So different iterations over time. As you can see in the picture, we keep our satellites as small and light as possible by reducing the size of traditional satellite components so that they fit. And this is just for scale. What you see here on the screen is each satellite's the size of a shoebox, more or less. So they are really compact and at the same time powerful. Well, creating this constellation, having it formed with this type of satellites really is what allows us to scan the Earth every single day. And you can see in this graph how we have increased our capacity in terms of area collection, right? So on the left side, we can see just area in terms of square kilometers, in millions of square kilometers. And on the right side, the evolution over time of that area collection. You can see the different, what we call the different flocks. Those are, let's say, different batches of satellites that we send up to space. And whenever we incorporate a new batch of satellites, of course, the capability and the amount of area that we can collect just increases. So just with time, as we build our constellation, we have reached a stable, let's say, number in terms of area collection that we are maintaining in a constantly, over time, ensuring that there are new satellites being launched as those satellites basically go back into the Earth. By the way, and I believe there's going to be a launch of PlanetScope satellites very soon as well. So this is a constant and ongoing process, always at Planet. The different, let's say, the variation here you can see on the graph, just for curiosity, is basically, we put satellites up, so we increase that capacity, but sometimes those satellites, which are very small, are very, very slowly going back into the atmosphere and getting burned, right? So whenever that happens, our capacity to collect data with those decreases, and that's why we're going to this peak and valley pattern. Those satellites, by the way, the ones you were seeing here are basically don't have an active way of controlling their orbits. So what we do is we use the solar panels to steer them and use the very, very reduced drag that is still at that altitude in their orbit to control their descent over the Earth to the atmosphere. And that's how we operate them, and we align their orbits. But we have, let's say, no way of pushing them up, which is something very common also for all the satellites. So yeah, that's just a curiosity for you to understand the constellation in some details. Okay, so I'm checking the questions here. First of all, thanks for the questions. So I'm seeing this one. What's the targeted age group? Well, to be honest, we are not looking for any particular age group. Maybe Sai, if you want to comment on that, but for us, everyone is welcome. As far as you bring an idea and want to learn something, you are more than welcome to join. Yeah. And there's this other question: what do we mean by area collection? By area collection, we mean the square kilometers that are collected in imagery. So when we take a picture from the satellite, the product has a specific footprint, right? We are covering, let's say, 10 by 10 kilometers for that acquisition. So if we put together the capacity that all the satellites have to cover the Earth, that's what we get here. And basically you see that with the satellites, every single day we can capture up to, let's say, if we take the latest number here on the graph, around 250 million square kilometers per day. So that's our ability, that's the amount of area that we can cover in a day with our constellation. Yeah, definitely. So the question here, if I have some images that we can share during the presentation, yeah, definitely. We're going to see some images here. And I'll point you to actually to a website where you can, just go over some nice images and get a feeling of how it looks if it's if you are not used to see satellite imagery, for sure. Okay. So let's go into the details. Let's understand our satellites, and let's see what we are working with. So Planet's fleet of satellites today, as of today, includes more than 200 satellites in what we call two distinct constellations. Constellation is just a group of satellites that work together. So on the left side, we have the PlanetScope constellation, which is made of the Dove satellites, which we were seeing before in the previous slide. So as we just mentioned, they are about the size of a shoebox, and they image the Earth landmass almost every single day. On the right side, on the other hand, we have what we call the SkySat constellation. And this one in particular is made of larger satellites, about the size of a mini fridge, for you to understand. And in this case, they are used to collect imagery at assigned locations. And we call the process of assigning a satellite to collect imagery at a requested location as a tasking satellite, or tasking the satellite. So in this case, on the right side, the SkySat satellite produces imagery that has higher resolution, approximately around 50 centimeters per pixel. And at this resolution, you can, just to give you a sense, you can count cars, you can assess building damage after a natural disaster, and gives you a great level of detail. So again, the Dove satellites are constantly monitoring. So those are satellites that are all the time acquiring products. It's a monitoring mission. On the other hand, the SkySat constellation is a tasking constellation. It means that it is the user, it is you who says, I want an image of this satellite over this specific area at a specific time. So, as I was saying before, if we focus on the PlanetScope constellation, right, so the one we were seeing here, for this hackathon, we're going to be mainly working with the PlanetScope constellation. So I want to go into the details of this one and make you understand the characteristics of this satellite in particular, and the type of data you will be getting. So let me monitor the questions. Okay. So what we see here is the evolution of the Dove satellite over time. As I was mentioning at the beginning, we have been building around 17, or we produced 17 iterations of the design, but those iterations basically are, or were, or have been consolidated in 3 different versions of the satellite that were sent, let's say, to space as a final build. So what you see here is the on the left side, the Dove Classic, the Dove R, and the Super Dove. That's the names we give to these different builds of the Dove satellite. So while Dove satellites are called by name in, let's say, in Planet Explorer, in Planet, it is also useful to understand that the technical specifications we see below them, in this case, the instrument IDs for the various Dove generations, especially because this is a parameter we will be using a lot in our APIs when we are looking for satellite imagery. So basically what we are saying here is that for every single satellite which has its own name, Dove Classic, Dove R, and Super Dove, there is an associated ID for the instrument. The instrument in the satellite here, we're talking about let's say, the telescope. Let's say the part of the satellite that's taking care of making the actual acquisition and which drives the characteristics of the data. So you see here that for each build, we have a specific name. We will be coming back to this name next week when we are all together there. I will be coming back to this parameter and you will see where it's useful. But for now, just remember that every satellite has an instrument, because that's a new version of an instrument, and that instrument has a specific name. You can also see below the improvements that we have been doing in the scene side and on the spectral bands. So you see how we have pushed our scene size over with time, with the latest versions of the satellite. And what you can see here is also the addition of spectral bands. Spectral bands over the spectrum, right? So basically the latest version of the Super Dove satellite has not only the typical RGB bands, those would be the bands that are acquired in the red, blue, and green channel. As you can see, we also have other bands in the green too, in the red edge part of the spectrum, in the near infrared, etc., which are basically key to monitor many things, amongst them agricultural patterns and many other things. For example, we have a coastal blue band, which allows us to make studies over coastal areas, meaning we can do bathymetry analysis, obviously in areas that are not very shallow, of course. So I have this question here. What are the differences between these satellites and Sentinel-2? I see one of them is the number of bands. Yeah, great point here. And I will make sure to address this properly. I have a slide for that so you understand how we compare to Sentinel-2. Thanks for the question. Okay, so by the way, and just coming back to these bands, Dove Classic, the one you see in the middle, and Dove R have the traditional 4 bands, as I just mentioned, and for Super Dove, we have these added bands. And be aware that Dove Classic and Dove R no longer collect images. So those are builds of satellites that are already, let's say, out of work. They have been changed by the newest version. But of course, all the imagery that they produce over time is available in Planet Archive, and of course can be exploited and should be exploited if you're looking for this temporal line analysis. So if we focus on the latest iteration, the Super Dove, this is the, let's say, the current version right now. Let's go into the details. So what you see here in the slide is just a summary of the technical specifications of the satellite. What we see, first of all, is the number of satellites that are making the constellation. We see the orbit altitude. So we have those satellites around 475, let's say around 500 kilometers of altitude in their orbit. They give us a ground surface distance of around 3.7, 3 to 4 meters. And that's per pixel, and collect the acquisition in terms of spectral bands is what we just mentioned. So coming back to this, the Dove satellites have no propulsion. To give you an understanding of the satellites, we mentioned already this before, but want to insist here, the Dove satellites here, they don't have an active propulsion system, and they are, once they are launched and put in their orbits, they are constantly sinking from that moment, right? After launch, they start, this is just pure physics, they start to sink into the atmosphere due to the gravity. So they have a limited lifetime because of that. However, we are still managing to control their position relative to each other by rotating them, by increasing or decreasing the drag. And we do that by adapting, as I mentioned before, those solar panels, and that allow us to take advantage of the very little drag that is still available at those altitudes up in space. So what you see here is a first image. And by the way, those are images of the satellite already for the question I got. So what we see here is a comparison of an old acquisition from a previous generation of Dove satellite, and on the right side, the same acquisition done by the newest version. So basically what we see here is an improvement in color and vibrancy, of course, an improvement also in spatial resolution, and basically an overall just greater accuracy for analysis. So everything, or let's say the algorithms that you may run on top of the newest imagery is just going to be based on top of data that is better fitted for the task. So gives you a visual sense here on let's say the effect of that constant evolution, that constant research we are doing at Planet to bring the latest technology available up to our satellites. Going back to Sentinel-2 and this question here, what you can see is basically a comparison between the Sentinel-2 mission, which for those of you maybe that don't know is an open mission from the European Union. And it's kind of, together with the Lancet program from the US, it's one of the, let's say, gold standards in Earth observation. So we see here how we are aligning our spectral bands of our satellites with Sentinel-2. And obviously this has a particular purpose. It's not done randomly. And it's because we want to make sure that the data gathered by the PlanetScope constellation is compatible in terms of spectral bands with Sentinel-2. So you can see here the bands of Sentinel-2 and the different bands of the different generations of the satellite. So right now we focus on the bottom part, which is the latest satellite, the Super Dove. You see we have also a coastal blue band, just like Sentinel-2. We have the RGB channels, of course. We have a second green, in this case here, which is not available in Sentinel-2, but we do have it. We have a yellow band, which is not in Sentinel-2, but I mean, we are complementing there the mission. We have the near-infrared band, and well, here we can see some alignment in this part of the spectrum. So 2 points here to mention. First of all, see this overlap between the bands, which again allow you to run analysis with Sentinel-2 and PlanetScope, but also pay attention to the shape of these spectral bands. So as you can see, the first generations of the spectral bands were less defined, as you can see here on the graph. But nowadays, the spectral bands of SuperDove are very sharp. Let's say they start at a specific point and they finish there. And this is something that's relevant when creating this type of instruments. We want to make sure that we capture radiation over a specific part of the spectrum, and we are very strict on those limits to avoid, let's say, having noise in the data that's not coming from where we want. So here you have this idea. And of course, if we compare PlanetScope with Landsat, with Sentinel-2, with these open missions, it's not only a comparison that we do in terms of spectral bands, not only in terms of spatial resolution. We've seen already we are with PlanetScope working with 3 to 4 pixel size, 3 to 4 meters in pixel size. But of course, we are also adding an advantage here, which is the temporal resolution, how often we are making those acquisitions. As I mentioned at the very beginning of my presentation, we are doing it globally for almost every single day. And here you have a representation of that. This is an area that where we have run the example, right? This is the imagery that is available in this case with the Landsat program, with the Landsat 8. And well, you can see we have a couple of acquisitions on the 4th and on the 20th. And the rest of the time, well, there's basically just no data. That satellite has its characteristics, and that's how the data is captured. Of course, if we are unlucky and the day that satellite passes over our area, it is cloudy, well, then the acquisition is not going to be, let's say, very useful. And this is where the temporal resolution comes into place. If I add now to this Landsat acquisition schedule what's available from Sentinel-2, as you can see, there are more images. Sentinel-2 has a better spatial resolution, spatial and temporal resolution than Landsat, and you see the effect of that. We have more imagery, but still you see, for example, we have 2 full weeks here without an update, because the dates the satellite was passing, it was just not available. So you can imagine if we are monitoring food security, a flood, or a drought, or a deforestation, or agricultural patterns, we might miss the actual event because we don't have acquisitions, and the day we have them, they are cloudy. So if we put into the game the imagery that is available from Planet, of course, we are still dealing with clouds. Those are optical satellites, so we have the same story here. But because we have this almost daily scan, we are able to just basically provide more information in the amount of time that you might be interested on. Okay, so very quickly, and just to give you an idea, we've talked about the PlanetScope. We have the clear picture already of this satellite. And this is the one we will be using during the hackathon, and the one you will be having access to. Just a slide here on SkySat, which is our very high resolution satellite. Again, this is not part of the data that will be made available, but I want you to be aware of so that you know what can be done with satellite data. So here we have a picture of the SkySat satellite. As you can see, it's much more defined, and basically this is the effect of the pixel size. Here we have a pixel size of 50 centimeters. So every single pixel in the image represents 50 by 50 centimeters on the ground. And this just allows us to capture much higher level of details in terms of what can be distinguished in the scene. Again, this is, as I mentioned before, a tasking satellite. So it's not daily scanning the whole globe, but it's up to the users to define, hey, I want a picture, or I want a product, an acquisition of the satellite over an area over this time. And then we send that order to the satellite, or basically you send it yourself, because that's kind of an automated system. And then whenever that happens, then it comes back to you. So you see here, we have less satellites because we are not covering the whole Earth every single day. We have less capacity in terms of acquiring products per day, obviously. And in terms of spectral bands, for this satellite, we have the RGB, the near-infrared, and the panchromatic. So I would say a default setup in terms of bands for VHR, for very high resolution satellites. Okay, so I'm going to actually skip those slides because I don't want to waste your time here, but just to be aware that, those satellites need to be tasked and they are made available. And one of the combinations that we do a lot here in Planet is to combine the power of one of the let's say the PlanetScope constellation, which is everyday acquiring products, and a very high resolution, right? So this concept that we call tip and queue, where we run an application with PlanetScope. Let's say, the users run an application like trying to detect a noise spill somewhere. Well, that's with the PlanetScope that can be that location can be scanned every single day, and whenever an algorithm that you have put in place or anything detects that something is happening, we can automatically task a very high resolution imagery over that area and just get a better sense. So all of this is just to give you the idea of how to monitor and use this data to really take action and understand what's happening. Take this example, the same could happen with other applications, right? Imagine deforestation. If I see with PlanetScope every single day that there is a trend in deforestation in an area, I can quickly task a very high resolution image and just get a better understanding of what's happening on the ground very quickly. So not only we have those constellations, those are, let's say, the active constellations, but with Planet, there is also an access to an old archive coming from a previous satellite. And just very quickly here, don't want to bother you with these details, but be aware that there is an archive that starts from 2009. So from 2009, we have already acquisitions, and we are building this Planet archive over with this previous mission that was in place before, and right now it's not anymore operational. The satellites just were out of order. So in this animation, and I hope you can see it properly on your screens, what we see is just a little example of how the orbits of the satellites are working together. So we have the Earth rotating, and you see these lines with the Dove satellites. So they have this what we call a polar orbit, and they're going this way. And as you can see, because we have many satellites, we are able to basically scan the Earth as we go over. On the right side, you've seen we have some green, kind of blue lines. Those are the constellation, the orbits of the SkySat satellites. And just I know there are a lot of lines, but basically see how the purple and blue lines kind of follow a similar pattern. So they have these what we call, similar orbits, and these allow us to actually make those combinations to scan the Earth with one type of satellite, with the Super Dove, and then have in a very similar orbit the very high resolution satellites so that they can quickly adapt to that. On top of that, we also have these kind of orange lines that, as you can see, they are more inclined in their orbits. And this is just a trick with, not a trick, but this is a selection of orbit that's put in place to ensure that we can cover specific parts of the Earth that usually are very difficult or very competitive to task a satellite. A satellite has a certain limitation in terms of how many images can acquire, and limitations that are linked to the memory in the satellite, the connection to the ground stations, to the antennas. So by placing satellites in different orbits, we are able to capture areas that usually are very demanding and where there's a lot of competence of acquisition with other users. So you see here basically the setup of those orbits and how well they work together to really offer this daily scan and this flexibility to get acquisitions quickly. Okay, so coming back and finishing this first part of the session, I just want to finish it with an overview of what we do at Planet with this data, right? So we've seen the constellations, we've gone into the details of the satellites and the constellations and so on. And the whole idea here is based on that, offer a broad suite of solutions. What you see here in the slide is basically what the main topics in which you can work with Planet. You can work with monitoring applications, thanks to the PlanetScope constellation. We know already daily revisit 3.7 meter pixel size. We also have the tasking capacity with the SkySat, so very high resolution imagery on demand. And of course, out of this data, already at Planet, we build, let's say, products on top of that. We have base maps. Basically, those are, let's say, mosaics where we put together all the imagery that's available, for example, for PlanetScope, and we create a seamless cloud-free product over an area, etc. We have access to the Planet Archive. This is especially important if we are trying to understand the temporal behavior of our targets. For example, if we are looking at food security, or we want to understand what are the agricultural patterns over an area, well, it's just very it's a great advantage to be able to look back in time and see what has happened before and compare that to what's happening now. So again, a very powerful and useful archive that is available on Planet. And we also have what we call the analytics. Basically, those are machine learning models that we run on top of our data to deliver certain analysis, like the detection of buildings, roads, and aircrafts, vessels, etc. But again, this is just to give you an overview of what's the extent of solutions that are available at Planet, and to put you into the context of where are you going to be working and with which data. So we will be focusing with PlanetScope and these monitoring capabilities, but this is just a part of the whole picture of what's available here at Planet. So, of course, I will be sending, I'm going to finish here this first part of the presentation. We will make sure we send you these slides. And I'm just leaving you here with some resources, some links to technical documentation where you can go deeper into the explanations we've seen today. And this is really something I encourage you to do during this weekend and until next Monday, just before the hackathon. Just go over, with no particular objective, but just go over the technical documentation, go through, just read, play a little bit with it. And I'm sure if you're not familiar with Planet, this is really going to help you and going to make the difference for the next sessions we have next week. So I'm going to check the questions here, and I'm going to move on to my next presentation. And of course, if there's any question, please just let me know. Okay. So we're getting here discussion, the Planet data. Okay, so is the Planet data ready to use, or do we need to make any specific corrections like radiometric correction, etc.? Well, that's a great question. Actually, that's what we are going to address in this presentation right now. But short answer here is, yeah, the data is corrected. It can be made available to you with these type of corrections that are typical: radiometric, surface reflectance, or atmospheric correction, let's say. Geometric distortions are corrected as well. So the data can be accessed in many ways. And one of the ways is definitely to have it ready to use for you. We're going to see that now in detail. Thanks for the question. Okay. So what we're going to do now in this part of the presentation is to go a little bit into the details of the products you're going to be working specifically next week. So next week, as you saw in the agenda, we're going to be working with APIs. So basically, I'm going to show you how to access all of these in a very, let's say, operational, professional way. But of course, I want to make sure that you understand what you are accessing and what are those details of this imagery. So we're going to cover the PlanetScope imagery products. So understanding out of this satellite that we have seen, and we know the characteristics of the satellite, but out of that, there are products, there are acquisitions, and I want to make sure we get the details of those products. And then we're just going to go over three other things. The Planet Archive, very briefly, we've talked already about it. And then two concepts that are fundamental and that we will be working with next week, which is what we call the usable data mask and the items and assets. So let's go over this. So here you can see, first of all, some extra details about this evolution of satellites that we have. So remember, with PlanetScope, we have gone over 3 different builds. Every single consolidated version had its own name: Dove Classic, Dove R, and Super Dove. And each of those satellites had a specific telescope, a specific instrument on board, which with its specific ID. Here you can read the description of it, but just the point here is to be aware of that and be aware that each single satellite version had its own dedicated metadata, let's say, for the telescope. So this is something we will come back next week when we are doing the API training, and we will see how we can use that. Basically, the usefulness here is the fact of being able to query the Planet Archive and say, hey, I want data just for this specific version of the satellite because I want to build my application over the characteristics of those acquisitions. So the first thing we need to understand when we access PlanetScope data is that we can have two types of products. They can be either what we call basic scenes or ortho scenes. So if you're familiar with satellite imagery of missions or anything like that, this is, I would say, something common. You can access the image, and actually this comes back to the question we just got. You can access the data in a basic format, let's say in a way where we have not run at Planet any particular correction. So we haven't done, for example, a geometric correction. We haven't projected the data. We haven't run any atmospheric correction. So the data, as the name suggests, is rather basic. And on the other hand, we have the ortho scenes, where indeed we have already applied a correction for the geometric distortions that happen. This is just pure physics. When we take let's say a picture of the Earth, right? There is topography, and this changes it creates some distortions in the imagery. So we have in the ortho scenes corrected that. We have run atmospheric corrections as well, so you can get surface reflectance or top of the atmosphere reflectance. That's up to you. You have also run some color corrections, so the data looks better, etc. So you have already this flexibility to access the data in one way or the other. So what you can see in this slide is basically, it's just to go over the same concept in a different way. What we see here is the typical workflow that happens when the satellite takes an acquisition, and then that acquisition is sent back to Earth to the ground segment, right? We have some antennas that collect that information, and then this goes into our archive, and there is some internal processes to make that data available to you. So what you see on the graph here is the different paths that the acquisitions follow. They are acquired by the satellite. They are what we call raw data. And then they go over a set of internal processes. And then you can access that specific acquisition from the satellite as a basic product. So we know already a basic scene is that one that has no further corrections. But that same satellite acquisition can be accessed at a different level. For example, the ortho scene, where we have those corrections being available. And as you can see, we have different products for the ortho scenes. So we have the visual product, we have the analytic, and each one has different characteristics. For example, the visual one has only the RGB bands, the analytic has all the bands, etc., etc. So those are, in the end, different ways, different versions of accessing the same satellite acquisition. And the whole idea here is to give you the flexibility to take whatever you want, whatever fits you better. There is people that want to run their own geometric distortions corrections because they have their own digital elevation model, or there's people that want to run their own atmospheric correction because they have that information on their side. So that's fine. You can do it with Planet. We just give you the data in different versions, different assets that we call, so that you can adapt to it better. So we're going to hear the question of, since when is the data available for PlanetScope? So this goes back to the idea of the Planet Archive. And for PlanetScope, I believe data is available from 2013, if I'm not mistaken, if not 13, 14. So we have already, well, we are 2023. So yeah, a large archive for PlanetScope. But of course, I mean, we'll talk about the Planet Archive later. Don't want to change here the topic. Very briefly here about the base maps. I don't want to cover that too much in detail, but just to give you a sense that out of Planet Scope, what we do as well is to create those base maps. So basically what we do here, this is, let's say, the Central America. And what we've done is we've put together all the acquisitions of the satellite over this area for a given time, let's say a month. And we have selected the best images available, and we've created this seamless cloud-free mosaic. We do them by default at Planet globally. So we create a cloud-free mosaic for every single month global. And we also do them quarterly, and we can do them also weekly or at a custom pace. So yeah, here I'm just leaving you with some technical characteristics. I'm not spending much time here, just for you to know, because we will be working mainly with the Planet Scope scenes, but I want you to be aware at least of this. So moving on into our items here, the next thing is the Planet Archive. So again, coming back to the questions. So as you can see, there is a large and very deep archive of planet data globally. So as you can see here on this little picture, we can see the total number of images that are captured, and you see it's really large. And of course, this is something that's by nature dynamic. Every single day we put new imagery available everywhere on the Earth. Obviously, the areas that are more like these tropical forests that are a little bit more challenging in terms of cloud cover and so on, but still we managed to have a great number of captures available. So more than 2,000 images available for any given location on Earth. As I mentioned earlier, a deep historical archive. We can go back in time many years and make you understand what's available there. And also be aware that within the Planet Archive, you also have access to let's say the Planet Scope imagery, but also the Rapid Eye Archive. So remember, this was an old mission that gave us data from 2009, so even before Planet Scope. And of course, we have Landsat and Sentinel-2 data within our archive, so you can very easily, using the same APIs and using the same tools and so on that you build for Planet Scope, you can use the Planet Archive to go even back in time. For Landsat, I believe the starting time would be 1970s or so. So we're talking here about decades that we can go back in time, joining Landsat and Planet. So two concepts here now that I want to focus on that we will be using a lot next week when we start to work with the data and build applications. And this is the concept of the usable data mask and items and assets. So when I talk about usable data mask, what I'm talking is that for every single satellite acquisition that we make, of course, we know there are clouds. We are working with optical data. So clouds is just part of the game. And usually, if you have worked with satellite data earlier, one of the first tasks someone has to do is to take care of the clouds. We need to identify which are the pixels that are being covered by a cloud or by a cloud shadow, or maybe has a little bit of haze, so that we can remove that out of our analysis if that's something we want. So this is a tedious task, and be aware that with Planet we have what we call the usable data mask, which is basically a layer, a raster layer that comes together with every single satellite acquisition, and that identifies if a pixel is a clear pixel, so it's a, let's say, ready to be used, or if that specific pixel is cloudy, so there is a cloud on top of it, or it is affected by shadows or by different categories that we have. So here in the slide, you can see a little bit of representation that we have here, satellite acquisition over an area, which of course had clouds, and you see the effect of this cloud, of this mask. So we have some pixels identified as clouds, shadows. You can see here the different categories that we classify. And again, this is very handy. It comes with every single acquisition, and you can imagine whenever you're building something out of the data, this is well, something fundamental to be aware of because at some point you might want to remove those pixels or just treat them in a different way. And we provide you that information already, so you can skip that step. Last visualization here. So this is, I mean, in a presentation style, this is how the UDM looks like. Basically, this is a raster layer that has different bands. This is a multi-band geotiff, and each band is binary, right? So each band is true or false for a given class. In this case, we have here snow, shadow. So you can imagine, let's say white means positive and black means negative. In this case, 1 and 0. And by putting all this information for the different classes together, we can just create, for example, here I'm taking the image and I'm applying the clear mask. So the layer that identifies the pixels are clear, obviously, by the name, and we just get this clean representation. Okay, and last item here is the item and assets. That's something we've covered already. In the previous slides, I've mentioned it, but I didn't call it by its name. So yeah, now let's put a name to that. So what do we mean by item and assets when we talk about planet data? So an item is every single acquisition of a satellite that goes into our archive, right? So the satellite makes the acquisition, it is sent back from space to Earth, and it enters our database. So that's an item. And each one of those items gets a metadata attached to it, which is basically that acquisition comes from that satellite or that constellation, right? So we need to identify in our archive if an element entering the archive comes from PlanetScope, or it comes from SkySat, or if it's an acquisition of PlanetScope, but in a different processing level, etc. So those are things that we use to categorize the elements that are within the archive. So item type. Then we have, well, here you have basically a list. So for example, those are the different metadata that we assign to these items that enter the archive, right? So it can be a PlanetScope scene, it can be a rapid eye scene from the previous constellation, it can be also like a SkySat, etc. So you can see here the list. You don't need to learn this by heart. We will be working with PlanetScope scenes, but be aware that by PlanetScope scene, we are referring to this concept of item type. As I was saying before, when I was showing you this graph where we saw the path that a satellite acquisition makes through the different processes at Planet, I was talking and saying that every single acquisition of the satellite, it's made available at different in different ways, in different versions, right? So remember, we had the basic scenes, we have the ortho scenes, etc. So these different versions is what we call an asset type. So for a given satellite acquisition, you can access that specific acquisition as a basic analytic or as an analytic surface reflectance, as a visual version. So all those are different versions of the same acquisition. And the idea of having this list, which by the way, here is just a summary of it, it's much larger, but again, you don't need to learn this by heart. We will go through the details once we start to work with the data next week. Well, the different versions, as I said before, are just there to adapt to your needs. If you don't need a surface reflectance, then don't take this asset, take another one, because you're going to save a lot of processing and storage capacity. So there is obviously a link between items and assets. So you can see it here. So for a given acquisition that goes into the archive as a PlanetScope scene, then a specific number of versions is made available. So as you can see, this is very extensive. No worries on that. And just be aware that there is flexibility. I think this is the key message here. There are different ways of accessing that, and we can adapt to your application. And the reason that I just mentioned, and this is my last slide here, is to emphasize that this flexibility that we offer is key, because satellite data can be heavy. I mean, the files by itself can be heavy in your computers, in your servers, etc. especially when working with Planet, where we have for a given area an image every day, the data volume can increase a lot and very quickly. So as you can see here in this table, different assets have different spectral bands, have different, let's say, content inside. And you see their weight in terms of megabytes changes a lot, right? We go from something that's around half a gigabyte to a single product that can be around 1.5 gigabytes. So that's 3 times the weight. If I tell you that you need to build an archive with 1,000 images, you can imagine if we multiply 1.5 gigabytes by 1,000, we are dealing here with a potential issue. So that's why we offer that flexibility, basically. Okay, so finishing here, this part of the presentation, I'm going to now move into a demo. We're going to start to see some images now. But again, leaving you here with these resources that I'll make sure we send you so you can start to read by your own. I will also send by the end of this session the links here on the chat. I think that's also going to be useful, so you get it straight away after this talk. But again, everything is documented, of course. The documentation, the technical documentation is open and is available, is on the internet. And yeah, so don't worry if you're missing some details, you can come back and read. And of course, ask me if you prefer it. Okay, so let's go to the last part of the slides before I go into the demo and we go to the end of this session. And it's where I want to talk a little bit about the Planet platform and what we mean by that. So when we talk about, so we've talked about the satellites, we've talked about their characteristics, the constellations, and we just saw the details of the products that come out of the satellites, right? So we've talked about those images and their characteristics, etc. So you know already what you're going to be working with. You know what are the satellite specs and so on. So what you are missing right now is well, how to access all of this. And that's what we call the Planet platform, right? The set of tools that we make available here at Planet to our users so that they can access all this data. So we're going to go through that. Basically, this covers what we call the web applications. So that's what I'm going to demo today. We're going to see how we can just check for imagery. We also have, and this is for you to be aware, we have dedicated plugins in Planet that are compatible with the most common GIS solvers. So you see here ArcGIS, QGIS. We also have it with Google Earth Engine. So you can integrate the data within those ecosystems directly. And this is particularly useful, I would say, if you are looking forward to work that way. So for example, if next week, if you are very familiar with QGIS and you want to stay there, that's something possible. And then we have the APIs, which is basically what we're going to cover next week together, which is really the most advanced level of accessing Planet data and what really allows you to build applications and go operational with the data. So first slide before going to the demos is that I want you to think of Planet as almost as an end-to-end system, right? So we at Planet not only design and do the research to create the satellites, we build the satellites, well, we put them up in space, and once they are put there, we operate their orbits and we take care of the whole, let's say, space side of business. But of course, that's not the end of the story. We then have to take that data back to Earth with our ground stations. Once that data is back to Earth, we need to process it, right? We just saw it. There's a bunch of internal steps that need to happen so the data is made available to you. And the very last step, and this is where we are now, is to make the data available to users and for users to be able to access and retrieve data in a logic way. Of course, as you can imagine, the data is massive, and we need to provide you with tools, with ways to narrow down your searches and identify the products of interest. Otherwise, it would be rather complex. So for that, we have put in place different applications, different platforms that allow you to actually do that. And that's what I want to do now. So what I'm going to demo you is the Planet Explorer. This is the web interface where we can just go and see the data that is available over an area. So you see how to do that in a very graphical and case-by-case approach in a website. Again, next week, we will go into the more advanced one. So I'm going to log in here with my account, and we will cover, by the way, at the end of this session, the logistics about your accounts and so on, so you get access. I'm going to put on the chat this link. So I've put it in the chat, not in the Q&A. So here what we see is this web interface to access this front end to access the Planet archive and start to check the data that is available, right? So let's do a demo, for example. So let's say we're interested in imagery over, well, actually the place where we will be in is Raha. So I believe it's close to the airport over here. So let's see what's the available imagery that we have over this area. So this is, well, we have the map here. We can play a little bit with the reference image. We can remove different layers that we have here available. We also have, and those are, I would say, typical tools within this type of web application. For example, we also have the coordinates, so we know where we are. I mean, of course we know, but if we want the precise information, we have it there. And we have a bunch of tools, right? So we can measure area very easily. Once we do so, we can actually download this as a file. We can also measure distances here very easily. So just drawing a line here, we can understand what's size. Those are basically tools that whenever we are doing the data discovery, you know, sometimes it's needed to make those type of spatial calculations, and we have those tools available in the Planet Explorer for you. So if we're looking to do a search, the first thing, sorry, getting out battery here. Okay. Yeah, so just a second, I think I got my screen small. Sorry for that, just arranging my windows. There you go. So if we want to make a search, the first thing would be to, and this is kind of the step-by-step we will do with the APIs, but just in a different way. So the first thing would be to define our area of interest. So you see here, we can either upload a file that represents our area of interest. So that can be, if you're aware of these formats, that can be a shapefile, a GeoJSON, a KML, etc. Or we can actually draw an area of interest over here. So the moment we do that, the system is going to automatically tell us what's the latest imagery that is available over the area. So as you can see, for example, here, automatically on the left side, we got this panel that tells us, well, basically it points out to the acquisition on the 4th, then on the 3rd of October, and then we can just go back in time, 2nd, the 30, and so on. So you see here the cadence and how often we get that. So what one would do typically is to just go over this, and of course now we have a very long list. As you can see, this is massive. So now usually what you want to do is to put some filters to narrow this down, right? So for example, the easiest one would be the dates. Let's say we're interested of imagery between the 29 September and today. So I just clicked here, and I'm now applying this filter to the search. And as you can see now, the number of products is much smaller, of course. There are other filters we can pass to narrow down our search. For example, are we looking for imagery of SkySat, so the very high resolution, or not? So we can remove that. Are we looking for Sentinel-2 scenes or Landsat? So you see how those are integrated in the Planet archive. We can also run our search based on the spectral bands. So you remember we mentioned that the different versions of the Dove satellite have the latest version by them specifically has more spectral bands than the other. So we can query and ensure that those spectral bands are present in the data we get. We can also filter down by the instrument type. So you see here, we can select imagery for Super Dove or Dove Classic. Remember, those are satellites that are not producing data anymore. So if we are looking for very recent imagery, we are only going to get Super Dove. So this wouldn't be very useful. But if we are looking into the long term, back in time, we might be interested in adding these filters. And well, as you can see here, a bunch of other filters that are available. The most common, I would say, down here is the cloud cover, right? So can we remove the images over my selection that have a percentage in cloud cover that is above a certain threshold? This allows you basically to remove cloudy products and just have a better timeline. So parameters we can set, as you can see, and I don't want to cover them all. Some of them are rather advanced and maybe not needed by default. Not at least if you are not in a situation where you really need it. And usually, for example, the sun azimuth, the off-grid angle, you typically don't play with that, but it's there and it's possible. So you see a bunch of different filters that have as objective to allow you to narrow down this search and just have a better output. For example, let me add here the area coverage. The area coverage basically ensures that the products that we are getting are covering above a certain threshold, the area we have, right? So let's put that we want products that cover at least 50%. So as you can see now, I get images that cover fully my AOI, or at least from 50 to 100%. So if we want to look at the image, and of course we see here a little preview, but we can just put it on the map here. I'm going to remove the different layers so we see it. So this is the actual satellite acquisition over the place where we will be next week together. And this was yesterday. So this is how it is. So what we are seeing here is this streaming product. So I can zoom in and see a little bit. Of course, it's not that it's full resolution. This is kind of a preview, but gives you an idea of how your targeted area looks like, if there are clouds, if not. I mean, you can already recognize some patterns very, very clearly. Just to go over, the next logic step would be, okay, this is the data I want. Now I just want to download it so that I can have it and start processing it. So this is kind of a very easy process, I would say, kind of like a shopping online process. Let's say, for example, we want this particular image, we would add it to our order, and now we just go and let's say we start the checkout process. So in this process of ordering the imagery, we need to provide different parameters. For example, the first thing we need to define is if we want to download the data or if we want to host it in Explorer. Super quickly, we and you will be working with direct download. The hosted data is basically the option where we allow you to not download the data to your computer, but basically to have it online in your client account and just visualize it in its full resolution and both spectrally and spatially within the web interface. It's not going to be our case, so I don't want to focus your attention here. So usually you would want to download the data. So we select this option. We see there is also the possibility to change the file format. Usually you want to stay here. If you're working in the cloud with, cloud buckets and algorithms and so on, you might be interested in this version, but if it's not the case, then you can skip it. Then we're just gonna, do a test. Let's put a name to this order. So let's do SRTP webinar. And now we are almost at the last step, which is selecting the asset. So you remember during my presentation, I was talking, there is a satellite acquisition, and which is then made available to you in different versions. And those versions are what we call the assets, right? Which is already done. So here's where you have to make the choice of selecting which one you want. Obviously, this needs to be an informed decision. So you need to be aware of why you are selecting something. And I'm more than happy, and we will cover this next week to just understand the differences. When should I use something and when not? But yeah, there's a little description here that helps you on that process. But just be aware that, for example, when ordering data in Planet Explorer, you get that option. And let's now just, for example, select this one, surface reflectance for plants. Yeah, so once we select the assets, we are just almost ready to go. The only thing we need to specify is the tools. So when ordering data, we have defined this area of interest. So by default, the system, well, in this case, by default, the system is going to clip the imagery to this area, which is the one we have defined. This is the area of interest, right? However, the satellite acquisition, if I remove this option, is much larger. So this is the actual acquisition of the satellite. That's the footprint spatially. So we have the option to ask the Planet systems to either deliver the complete product, or to just clip it and give us only the area we want. Again, this is a decision that is based on your needs. If you really don't need the areas here because you have nothing to do here, then I would say it's better to clip it. It's going to save you processing time, storage volume, etc. There's other tools are available that we will go over next week. Composite just allows you to mosaic different products together, so you get a single file. And Harmonize is the tool that allows you to normalize your data against Sentinel-2, so that you can build time series that are even more compatible with that sensor. So again, you get these different options to customize your order. And basically here on the right side, we get this order summary, right? So it's going to be this name. We are ordering one single product in this case. And we get just a confirmation of the asset we are selecting, the data format, the fact that we are clipping, right? So if I remove the clip, then it's not present here. And the fact that we are also getting, it includes the usable data mask. So remember this multi-layer GeoTIFF that identifies pixels if they are cloudy or clear, etc. So if I press order, let's do it. I'm placing the order in the system, and well, now as you can see, the order is queued. So basically, now on the Planet side, we are starting to process the image, and we will be making it available to you in a few minutes. As you can see, once that happens, I will be able to click here on download zip, and then I will just get a zip folder with that. And I will also get, by the way, an email notifying me that the data is ready. Usually the question I get here is how much time do I need to wait? And this really depends on how much data you are asking. This is, for example, a single product with, I would say, a rather small area of interest. So I don't think it will take more than 15 minutes, I would say. But of course, if you are ordering 100 products or a larger AOI, then the waiting times are going to be different. But this is really where the API comes into place, because when we are going large in terms of the amount of products we are ordering, we really need to build things that are a little bit more operational and that can account for these times, etc. So I think there's a question. Let me just check that. So the question here is, which satellite data could we get from Planet, and does it provide high resolution and up to what scale? So just coming back to that question, as we addressed those topics already, the data you are getting from Planet comes from the satellites that Planet operates. So those are PlanetScope and SkySat. We also have an old constellation called RapidEye. And yes, we do have high resolution imagery. That would be the SkySat satellite that we mentioned earlier, and which gives you imagery up to 50 centimeters per pixel size. However, be aware that during this hackathon, during the scope of this hackathon, we are going to grant you access to PlanetScope. So the first constellation we've talked about, not to SkySat. And PineScope, just to emphasize on that, has 3 to 4 meter pixel size. Okay. So we've seen Planet Explorer. We've seen how to use this web interface to identify products of interest. As I mentioned, well, we have dedicated interfaces for the base maps. Again, I just want you to be aware of that. We will not be covering base maps in the hackathon, but just for you to be aware. As I was mentioning, we also have these integrations into these softwares. So that means QGIS, Esri, and Growth Engine. So we have official plugins in those softwares that you can install freely. And if you have a Planet account, then you can just do the same process as I've done in the website, but just within those softwares or development environments like Google Engine. And just finishing here with the Planet APIs, and just to let you know that, I mean, this would be the third way of accessing, let's say, Planet data, right? We have the web interfaces, the plugins, integrations, and the APIs. So this is what we're going to be focusing next week. We will be learning how to use them to basically do this data discovery and access. And the idea, again, of the hackathon is for you to be trained on that. And once you know how to access the data and let's say, filter down the archive and identify products of interest, once you have that, then on top of that, we ask you to just bring your ideas and work together towards a specific application that addresses a global challenge. So I don't want to jump into the content of the next week, but be aware of how we are framing the content that we will be seeing there. So we will be covering mainly the data and orders API. Again, don't want to go into details, but those are the APIs that really allow us to do the search and to order the data in bulk. So finishing now, again, a couple of resources. I'm gonna now take a few minutes to send you the links here, also in the Zoom chat. And what I would do now is to take the chance to, of course, answer any question you may have live. Also, to give you the chance to ask for any questions you may have about the hackathon in terms of its organization and scope. And I think it would be great if we can have also some time, the time we have left, to just get to know you. What's your background? What's your ideas for this opportunity? And well, just to understand a little bit who's on the other side. So while I wait for questions and maybe for someone to start the round on introductions, I'm just going to send some links on the Zoom chat here so that you have some documentation you can go over after this call. So yeah. Go ahead.
I would like to say that thank you, Miguel, for this amazing presentation. And guys, make sure to bring your laptops and don't forget them, because we would require to utilize them in the session. So whoever has questions, and if you guys want, let's start with quick introduction and your background, please, if you don't mind.
The first one takes the Brave prize. Yeah, go ahead. I'm not sure if they can unmute themselves or not directly, to be honest. I see someone has raised their hand. Can you confirm if you can unmute yourself?
Yes, go ahead, please.
They can only write in the chat. Okay, apologies. I was not aware of that, and I was asking for that. Yeah, so
they can only write, please. I'll write in chat. Okay. If you guys can do that, it would be appreciated. Just a quick background about your experience.
Okay, hi Jen. Just seeing here your feedback. Okay, that's great. That's great to know there's someone with that background in GIS and environmental science, let's say in general. Yeah, that's great. I think that's a perfect fit. Yeah, welcome to the hackathon. I think yeah, I'm sure you will find it useful, and it's just gonna be a great time together to solve doubts and go together in your development. So yeah, great to know. Okay. I see here also someone else with a background in urban change detection based on satellite imagery. Well, that's great, using deep learning. That's great. That's a great application. Definitely, I'm really looking forward to your ideas and how you put together the data towards different things. I think these type of events are really a great chance to see where people is bringing data. And yeah, we appreciate all of that. For this urban change detection, I think that's great, especially in the context of emergencies or in after or disaster and so on. Being able to detect that, I think that's great. We will see the fit of the data right to your applications. I think you will see it by yourself, but I think there's great potential there. So while others introduce themselves, I would say just reviewing a little bit the to-do for the next week. As Saif mentioned, please bring your laptops, bring a charger as well. It's going to be a long day, intensive with the computer. So yeah, make sure that we will have different break sessions, break times, right, for coffee and lunch. I would say also use this chance to network with SRTIP, with me, with your colleagues that are going to be present there. I think you can also use this chance to make great contacts that are going to help you. Yeah, just thinking of the logistics. We will be sending you the agenda, right? So, but just keep in mind, we are starting at 10 and 10 in the morning. So I would advise just come a little bit earlier to find your way to the rooms and set up everything, etc.
I think we will make the introduction, we'll keep the introduction for the face-to-face so that we can make it a nice icebreaker exercise before we start.
Yeah, that's great.
So all the participants will be there at once. Again, thank you, Miguel, for this amazing presentation. Every day I get to notice, especially working in SRTIP, that the more you know, you realize that the less you know. The more topics you start to cover, the more topics you start to learn more about, you'll have more appreciation to whatever is out there. So again, thank you, and we're looking forward to the hackathon. And thank you again, guys, for attending, and we'll see you soon, inshallah.
Yeah, thanks, Saif. Just for the last question that I'm seeing here while you were talking, I think it would be great to address it. So what would be the topic we will be working on? So what we're going to cover on the teaching side of the hackathon is this teaching on the tools so that you can access. So I think it would be great if you can, during this time, think of an application from your side. So let's say, for example, some people here saying, I work in change detection, or others maybe in environmental stuff. So if you bring that idea of, okay, let's develop something to see change in cities after a disaster, or let's see how we can monitor a flood. So if you bring that idea, then we're going to make sure you can access the data and you know how to do it, and you will have the time to develop that. So you will be working in groups. I will be around, and we can just discuss during that time all your applications, and I can just guide you towards that, and so on. So yeah, I think that's all said. Thanks, Saif, for the introduction. Indeed, the more one studies, the one less knows. But yeah, looking forward to see all of you next week. So yeah, hopefully you have a nice weekend over there, and I'll see you.
See you guys, and have a great day. Take care.